Happy 2026. Welcome for the first DigiPath Digest in 2026. This is number 34, and I'm proud of us.
Learn about the newest digital pathology trends in science and industry, meet the most interesting people in the niche, and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Alexandra Zhurov.
The last thing that we did last year, and there was a recap on the podcast and probably a video on YouTube channel as well, was the recap of 2025. That was December in London. You may see me walking through London and you will see the double-decker buses in the background as I recount what happened in 2025 in digital pathology. And I'm super excited about 2026 and the new developments. And of course, what else happened since the beginning of the year. So I know you've heard that several times, but I am working on the new version of the book. And everybody who has the book, and by the book, I mean Digital Pathology 101, all you need to know to start and continue your digital pathology journey. If you're new to the field, there is a free PDF on my website, and I'm going to give you a QR code right now. You should see it on the bottom of the screen now, the QR code to get the free PDF on the book. If you're connected on LinkedIn, you may be getting messages from me asking, hey, did you get the book already? Because there is a new version coming. I'm already on chapter 3 out of 5, so it's actually happening. 1 and 2 are updated, and obviously it's taking me longer than I wanted it to take me, even though I'm leveraging AI as hard as I can, because if I wasn't, it would take me even more time. So when you get this book, it's going to be the previous version, but don't worry, because everybody who has signed up, who had subscribed for the free PDF of whichever version is going to automatically get new versions. So and I see you guys are scanning the code, so thank you so much. That's an update. Then I was mentioning a couple of times something I was planning to do, and actually I'm committing to doing this on Valentine's, like as a Valentine special thing, is how to create expert presentations with AI. I have gathered like different tools. I have described my process. So at this conference in London, organized by Global Engage Digital Pathology and AI, I was speaking as well, and I used this process to prepare my presentation, to prepare the topic slides, and also to practice it. I did practice. I dread practicing. Once my slides are ready, I'm like, oh, let's just be done with it. Let's wing it. And I know that winging it is okay. I have a process and I actually practice, and it went better than without practicing. And in every presentation book, you're going to see practice, because then it's going to be so much better. But I know that we all are busy people, doctors, researchers, digital pathology trailblazers, who, when they are done with the slides, often 3 hours, if we're lucky, before we actually are presenting, then we're good to go. And we have enough experience, but there's a process that lets you practice without actually investing too much time in it. So that's going to be out there around Valentine's. If you're interested, let me know in the chat. AI presentations. Let's start. Automating clinical phenotyping using natural language processing. So this one is super cool. I think it's this one. You're going to see. But basically, so clinical phenotyping. What is that even? This is a group from Germany and New York, so international collaboration. So often there are studies, real-world studies, based on electronic health records, and they require manual chart review. And when we see the word manual, we know it's gonna be slow and labor-intensive, and it's not gonna be scalable, limited scalability, right? So they developed and compared computable phenotyping based on rules using the SPA-Psi framework, this SPACY or SPA Psi framework is a Python framework to coordinate large language models, and they had this framework and a large language model, GPT-4, for subphenotyping of patients with Crohn's disease, considering age diagnosis and disease behavior. So we have GPT-4. They worked with GPT-4. When you go to ChatGPT, there's already ChatGPT 5.2. So they had this framework. Let's call it SPACY framework. I don't know if I'm pronouncing this acronym correct. For the LLM-based approach, they use GPT-4 model, and they had data that included almost 50,000 clinical notes and 2,204 radiology reports from 584 Crohn's disease patients. And then they had a test set of 280 clinical texts. These texts were labeled at sentence level in addition to patient level ground truth data. And then they evaluated the algorithms for recall, precision, specificity values, F1. So all the parameters that we have for evaluating these models. And the results were similar or better performance using GPT-4 compared to the rules. On a note level, the F1 score is at least 0.9 for disease behavior and 0.82 for age at diagnosis. Patient level, this is a little lower, 0.6 for disease behavior, 0.71 for age at diagnosis. And the conclusion that they have here, this is the first study to explore computable phenotyping algorithm based on clinical narrative text, where prior inter-annotator agreements range from 0.54 to 0.98. And we know that all these inter-rater, inter-human comparisons, they always range from like 0.54, not too high. Sometimes they agree more, but in the pathology world, I always say, hey, if it's 0.7, then we're so in agreement. And then there's still 30% that we're not in agreement. So this underlines the potential of LLMs for computable phenotyping and may support large-scale cohort analysis from electronic health records and streamlined chart review process in the future. And now the heart is for plain language summary. So plain language summary, how cool is that? So they included it here, but basically what I read this one and I went, there are two other abstracts that are a little bit more complex. And I'm like, how about I ask my LLM, and I use chat, I use GPT, I use Claude. These are the main. Sometimes I ask Perplexity, which is like a LLM-powered search engine. But basically, I did a screenshot of this, and I'm like, can you explain it in plain language? And it did. So if you see an abstract that you would like to get explained in plain language, or you need to explain to somebody else in plain language, screenshot it and put it in ChatGPT. So let's do the plain language summary. Doctors and researchers often need to group patients by specific medical features. And these are the phenotyping, basically grouping patients by specific medical features. And much of this information is free text clinical notes rather than tabular or structured data. And I'm going to give you a comment on free text plus structured data efficiency. So here they had the patients with Crohn's disease, and that free text notes can include important details describing the disease course over time, such as bowel narrowing, strictures, abnormal openings, fistulas, problems with the area around the anus, and age at diagnosis. So how cool is that? They explain what the stricture is. They explain what a fistula is. This plain language summary, it's like kind of smartly written because it explains without like dumbing it down. And it aligns with a principle that I once learned. So never underestimate your audience intelligence, but never overestimate their prior knowledge. If you're listening to this, you're a highly intelligent healthcare professional or somebody involved in healthcare in one way or another. So by default, you're a super intelligent person, but you may not have the prior knowledge, right? So that's my goal, to explain things in a way that everybody understands them. And same counts for me, right? I do need to go back and check the computer vision terms. I'm a pathologist, so my expertise and main domain is pathology, but I do talk about things that are from computer vision, from AI, from whatever is happening in this space. So I do need to update my knowledge base as well on a regular basis. So anyway, hard for plain language explanation. I love that. Yes, because when we only use structured data, we often miss these details, like whatever happened there, whatever was written in the text. And reading notes by hand is very slow and costly. So we use NLPs, natural language processing, and LLMs, large language models, and they built 2 NLP approaches and created the new sentence level data sets to test them. And they say this method could save time in research and help clinicians flag people who may need extra care. I love this plain language summary. I don't know if that was a requirement of the journal. What is the journal? Let's check it. I love it. I like it. Sometimes they also ask for visual abstracts. That's cool. That's cool as well. But the plain language summary is the highlight of today. Let me know what you think. For using LLMs, I need to tell you a story. So using LLMs for clinical notes. That brings me to my latest visit. So related to that paper, using LLMs or using AI in healthcare. So I live in Fairfield, Pennsylvania. Fairfield is not a big town. I think it has 500 inhabitants. So you can imagine what kind of infrastructure we have in a town for 500 inhabitants. And then I go to the doctor for just a regular checkup. I got a spot, I think on the 31st of December, so last day of the year. And I go and just a regular checkup, right? Because I needed a refill for my prescription, and they wouldn't give me the refill because I didn't have the checkup for too long, right? So I go, and I learn that our little practice, well, it's a part of a chain, but that they use Ambient Scribe, which is this AI transcription thing where you can actually, you as a healthcare provider can have a natural conversation with the patient. You don't have to type and look at your screen and then pretend that you're actually paying attention to the face expressions of your patient, which you are not because you're typing what they're saying. So now they use this transcription service, Ambient Scribe, and I had a conversation with my provider, and it filled the clinical notes, everything, without her having to type it. So that was super cool. I felt proud that Fairfield is so advanced in terms of AI. One thing that I would improve is to actually inform people that this is happening about it. I think I asked about it, but I'm obviously interested in the topic. So we had a lengthy conversation that was probably longer than my checkup itself about AI, and that was cool. So AI in healthcare is happening. LLM for making bringing back the patient-provider relationship and contact are happening as well. And now let's go back to the papers. Zebra bodies recognition by artificial intelligence. A computational tool for Fabry nephropathy. So, greetings to Italy. This is a group from Italy, different universities in Italy. And Fabry disease is a rare lysosomal storage disorder caused by mutations in the GLA gene, GLA gene. And there's an accumulation of lysosomal substance. It's called globotriosylceramide, accumulation of globotriosylceramide. It has a very characteristic appearance on electron microscopy, right? But that's an advanced imaging technique. So they these lysosomes look like zebra, they have stripes. That's why they're called zebra bodies. But here we are talking. So the diagnosis, especially in females, is more difficult, and we need a renal biopsy to assess it, right? That this remains essential, and obviously interpretation requires expert pathologists. So here we did not use electron microscopy, which is like pretty straightforward, because I thought, oh, zebra bodies with AI on EM images, that's going to be a no-brainer. No. We used whole slide images, renal biopsies of Fabry nephropathy patients to develop and validate foamy podocyte screening AI tool. Foamy podocytes are a lot less characteristic, and you do need expert pathologists to recognize them, than these zebra bodies in electron microscopy. So they are basically like foamy cells, but they developed this AI tool that first it classifies glomeruli and then segments podocytes. And they evaluated the performance using standard metrics, and they designed a new zebra score to quantify disease burden and correlation with histological scores and clinical parameters. And they had a classification accuracy of 79% in identifying foamy podocytes. So this is a new AI screening tool that is supposed to support the pathologist. So let's highlight that. The AI-assisted Zebra pipeline highlights high-risk Fabry nephropathy features to support nephropathologists as a screening tool, right? So this is important because it's pathologist support. And, if you've been here or at any digital pathology conference, more than once, you will still hear the questions, hey, is it gonna take away the jobs? This is like part of a conversation every time there is a new AI tool. Is it okay? Are we gonna be less proficient in what we know? Like, it's a technology discussion, right? So here, important thing, it's a screening tool that helps the pathologist, and it recognizes these foamy podocytes. So we have 2 more to go. Yeah, this one is interesting as well, because it's about, can we save money with AI? And there is no discussion about healthcare without discussion about cost effectiveness or money in healthcare. So here we have cost effectiveness analysis of artificial intelligence for response prediction of neoadjuvant radiochemotherapy in locally advanced rectal cancer, locally advanced rectal cancer in the Netherlands. This one is from the Netherlands. And also we have authors from Poland. So greetings to Belgium, the Netherlands, Poland, and Italy again. Italy is very represented. This study aims to provide insights into the potential cost effectiveness of AI tool in the response prediction to neoadjuvant chemotherapy of stage 2-3, the rectal cancer. And this is the comparison to usual care. So this is a hypothetical study, right? It's not like, it's a model, it's modeling, right? So this study included a state transition Markov model from a Dutch societal perspective. Quality adjusted life years and costs were simulated over a 10-year horizon. And, the important word here is that they were simulated, right? We're hypothesizing about it, right? And then sensitivity analysis and a threshold analysis were performed. And we're going to see in a second what that means. And the results, like in the best case scenario, when everything works well, AI is performing well, that there was an incremental cost saving of 2.5 million euro per quality adjusted life years gained per 1,000 patients, right? So this is 1,000 patients and 2.5 million euro cost savings. Main drivers of cost effectiveness were the clinical complete response incidence and specificity of the tool. And cost effectiveness was maintained if the cost of AI was 1,100 euro and 2,100 euro. So they simulated what if this, like deploying this tool would cost over 1,000 euro. It was still cost effective to use it. Over 2,000, it was still cost effective, and performance at 0.85 and 0.90, which is very like good performance, right? So then the question arises, okay, if the deployment costs more, then at some point you lose the cost effectiveness. If the performance goes down, then obviously this is not a viable case anymore. So they say findings of this study present the economic impact of a hypothetical AI-based approach to treatment and treatment response prediction in stage 2-3 locally advanced rectal cancer patients who received neoadjuvant chemoradiotherapy and are eligible for consecutive surgery. And the results of the study highlight the complexity of healthcare decision making. I think, this is kind of no-brainer, but I think in general, it's so much easier to think in black and white and so much easier to make decisions when you only have like good and bad option, but there's often good and better or bad and worse and things like that. So there are a lot of nuances specifically to healthcare, and these models help. And if we're lucky and we have a great case scenario where everything is performing over 0.85, whichever metrics they chose, then we have a fantastic tool to save money. But if not, then we don't. But great exercise, I think. We have some comments that AI will increase productivity and efficiency in automation, and this has already impacted clinical labs. I think so. I think there are a lot of, how do I call them? I do call them low-hanging fruits, kind of AI tools, and I'm referring to workflow improvement tools, workflow redesign tools. Maybe we're going to get some papers next week or soon when agentic AI approaches are going to get published. So basically where you're trying not to replace or help the diagnostician in the diagnosis, but help them in their workflow, where they don't have to click millions of windows and lose time and patience and things like that. So definitely AI entering these areas of clinical labs is super valuable without threatening the expertise of the physician, doctor, healthcare provider. This is our last one, but that's an interesting one as well. A multi-expert deep learning framework with LLM-guided arbitration for multimodal histopathology prediction. And this is Cincinnati, Ohio, USA. So we all know that we have advanced a lot. Deep learning changed the landscape of computer vision, of computer-aided healthcare. Let's call it super broad, computer-aided healthcare, deep learning. One of my podcast guests, Andrew Janowick, called it as if we were given fire, like the invention of fire, deep learning in the broadest sense. And now transformers and transformer-based architectures made this fire even bigger. So this helped with improving the accuracy of computational pathology. But there are a lot of models being created, and conventional model ensembling strategies often lack adaptability and interpretability. What does that mean? These ensembling strategies. So let's say you are developing multiple models, and one model says one thing and the other model says a different thing, and then you have several more, and then you let them vote, or you ensemble, you collect all the results, and maybe you do, and they mention what this is, majority voting or aggregating this in a classical way. So because these models, multiple AI models, while they can provide complementary perspectives, the aggregating of their outputs is often insufficient for handling intermodal disagreement. So not only pathologists disagree, the models disagree as well. So what do we do with that? To address these challenges, the authors proposed a multi multi-expert framework that integrates diverse vision-based predictions and a clinical feature-based model with a large language model acting as an intelligent arbitrator. So we have like a third party. We have these models that go and assess something, and they have two data sets. And then we have the large language model that kind of looks at the reasoning of these models and picks the decision in a more intelligent, transparent way than just like some mathematical operations or whatever was done so far. So they leverage the contextual reasoning and explanation capabilities of LLMs, and their architecture dynamically synthesizes insights from both imaging and clinical data, resolving model conflicts. This is cool. And then it provides transparent, rational decisions. And what they used were two cancer histopathology data sets. There was one HMU-GCHE30K, and this is for gastric cancer, that only had pathology images. So this is important because that got me confused, because they have these two data sets and one of them only has pathology images, whereas the second data set, BCNB, which is breast cancer biopsy data set, is truly multimodal, contains pathology imaging and clinical information. So their proposed multi-expert LLM arbitrated framework, and they call it MELMA, multi-expert LLM arbitration, right? MELMA. Outperforms convolutional neural networks and transformers, which are currently de facto and state-of-art classification ensemble models, and their method has better overall results. And they tested different LLMs as arbitrators. So they took Llama, GPT variants, and Mistral, and their proposed framework outperforms strong single-agent CNN vision transformer baselines on the data sets, and they show that, and ablations show that learner per agent trust materially improves the arbitrator's decisions without altering prompts or data. And LLM-guided arbitration consistently provides more robust and explainable performance that individual models, conventional ensembling with majority vote. So here are these different conventional ensembling methods: the majority vote, uniform average, and meta-learners. So their LLM arbitration outperforms these. And so we have an option, promise an option that LLM-driven arbitration for building transparent and extensible AI systems in digital pathology. So for this first database of gastric cancer, I was like, okay, so what was it arbitrating if there were just images? So what it was looking at for these different models that it was arbitrating between. So there are different computer vision models that were giving some answers. And what it was looking at was, okay, how often was each of these models right? How consistent it was, what was the confidence in which this particular model predicted, and not just the majority voting or whatever the approaches were. So it can even go into unimodal models and figure out, okay, which reasoning of which model was better more times, and propose a kind of arbitration strategy, which I thought was pretty cool, because we are limited in doing that. And by we, I mean human observers. So you need to do it how did I learn that? By taking part in a project and these models have a lot of parameters, right? And we were only trying to do combinations of a couple of parameters and couple of performance metrics. And very quickly I was like, is there a software to do it? Because I am not able to visually decide, they're kind of good enough, but I am not looking at every cell. I'm not looking at every field of view. I'm then looking at the metrics. How do I know which one is better? And now we have an LLM-powered framework that can help us arbiter and provide some kind of justification. And then a human expert can go and figure out, okay, is this justification, does it make sense or not? And with that, I want to add something to, okay, take an abstract and ask an LLM to explain it to you in plain language. Ask like clarifying questions, because that was one of my clarifying questions. Like, oh, so how is this model arbitrating multimodally on a unimodal data set? So that's what it explained to me, but not in the first place. So if you have any questions, anything is confused, and sometimes the LLM is going to tell you, oh, no, most of the time it tells me, oh, great catch. Oh, and there was another thing I needed to tell you about. So obviously I have like some pop-up notifications on my phone. Let's see if I can find this one. Because when I saw this, I'm like, I need to tell it to the Trailblazers, because we were talking about it. When I had this problem. I think I told you the story that I was submitting like part of a publication, and like I read through my part. It was really solid. I knew it was based on my presentation, and then I like quickly used AI for references. So I don't feel that bad anymore. I felt very bad so nobody really caught it, but they gave me, maybe they caught it, but maybe they like wanted to give me the benefit of the doubt, because they told me, oh, can you format the references differently? And I went in and formatted them differently. And in the process of formatting them differently, I realized that they were fake. So it wasn't only me. Let me give you January 2026, so this month, an analysis by the AI detection startup GPT-0 revealed that more than 100 AI hallucinated citations were included in research papers accepted for the Neural IPS 2025. So without going into the details, I just screenshot this yesterday because I thought I have to tell it to the Trailblazers. So yeah, over 100 AI hallucinated citations. So for us, this information says, yes, you can leverage AI for citations, but you need to scrutinize it because it hallucinates. And I think it's getting, so at least since I wrote the book, it was first edition 2023, second edition is going to be 2026. When I wrote it, it would hallucinate in this like normal text output a lot more than right now. Right now, I feel it leveled up, but in these like very specific tasks, like the reference finding, reference generation, or stuff like that, it still hallucinates. If you find a tool that is actually optimized for that, let me know, because I was trying to find one a couple of months ago, last year. Obviously, last year is a couple of months ago, so we're in January. I didn't find anything specific. There are different ones for writing, different things. If you find anything, let me know. And thank you so much. Oh, and I have one more comment. Let's do this comment. By nowadays, there's a lot of fog in how AI can be implemented in order to help or boost effectively on pathology workflow. I think improving the efficiency of workflow is key. Yes, and something a cool presentation I listened to at the DPAI conference in London by Orly Ardon was about QC, quality control, because this quality control step, I mean, it is an integral part of producing slides, but then there was this additional QC step of quality control of scans. So not only in digital pathology, unlike radiology, maybe it's going to change with the direct to digital imaging technologies, but not only we still do the analog glass slide, we then scan it, and then on top of that, we quality control the scan, even though the glass was already QC'd. But because the different artifacts and different things are important in scanning, we need to do that. So she was talking about implementing a software for that, and I thought, hey, yes, this is something that is high leverage, low risk, and using AI in these situations helps, obviously, with workflow, with probably cost savings, or even maybe generating of revenue. But what it helps with most, and that was part of my conversation with my healthcare provider when I went to the doctor and we were talking AI, was like, hey, people are afraid. And I think we talked about a paper where where there was a mention of people, when there was a mention of AI being used in a clinical trial, they would withdraw from the clinical trial. I'm like, wow, that is not good. So anyway, there was this discussion about making it understandable, introducing it to the patients, introducing this also to healthcare providers to be comfortable with the tools, and implementing guardrails. This is an ongoing discussion. You're going to be hearing about it. But for today, let's grab a coffee, start our working day. Thank you so much for joining me. Next week, I'm going to have a new computer. Thank you so much for trailblazing this trail with me. Leave me comments if you're listening to the recording, and I talk to you in the next episode.